The label for this unit is disk operating systems, which is kind of a legacy term. We used the term disk operating system in the old days because one of the primary jobs of an operating system was to manage files, right? We needed a scalable and predictable way to manage files in a computer system, and a disk operating system would do that. In fact, one of the first operating systems from Microsoft was called DOS, Disk Operating System, right? Many of you have probably heard from that or heard about that. So we're going to discuss file management in this unit. Really, this unit is mostly about file management. A lot of this is going to be review from things that you hopefully have learned in other courses or just your day-to-day use of computers or in your previous Linux course. But we'll try to dive a little bit deeper into some of the other tools that the operating system affords us for managing files. So first, there are many system commands that are based on storage. I just talked about how early operating system, that was a primary job, right? Was managing files in the system. So there are commands for creating files and directories, for moving, renaming, copying, deleting, and so forth, right? All these basic commands. And we'll review some of these, and in the lab, you'll kind of have to use these a lot in all the labs, right? Because everything we do in Linux involves files. So you'll need these over and over again. But one important thing to remember about files is that while we view files and directories, right, that's how they're manifested to us in the operating system through our user interface, through things like a file explorer, or in this class when we use the command line in Bash. That's how we view them. But the way the operating system views them is as blocks and pointers or links and partitions. So let's talk about some of the terminology or vernacular that we're going to see in this unit. And throughout the course, really, a lot of these terms will come up. Things like file space, files themselves, directories, right? So directories contain files. Top-level directories. So, for example, etc, which we use a lot in this course because it's where a lot of config files are, is a top-level directory. We talk about top-level directories in more detail later. The path is how to get to a file or a directory, right? It can be relative or absolute, which we'll talk about. The current working directory is where you are located when you're using something like Bash to work with files and directories. A path variable tells the system where it can look for files if you're not going to indicate what the path is. We're going to talk about partitions later when we talk about disk management and also logical volume managers. And then really kind of getting to the low level, we'll talk about inodes, which are important to understand when we learn about hard links, and then symbolic links, which are ways to reference files in other directories rather. So first, let's talk about what a path is. Hopefully this is really review for most of you. You should be familiar with the path, but an absolute path, when we talk about an absolute path, we're always talking about a path that begins with the slash when we're talking about Linux. In Windows, it would be C: something, right? But in Linux, it starts with that /, which is also called root, right? So we're starting with root, and then we're indicating the path from root. So it's an absolute path because it always starts from the beginning from root. But a relative path is how to get to a file from where we currently are. So an absolute path never changes. No matter where you are in the system, you can always reference a file by its absolute path, whereas the relative path is going to change depending on where you are. So if I'm giving somebody directions from my house to get to the library, I might give them one set of directions, but if they're at the 7-Eleven trying to get to the library, the relative directions to get to that library are going to be a little bit different, right? Because they're starting from a different place. Just like a relative path in our system is always going to change depending on where you are in the system. So again, absolute is always the same, relative is going to change. So for that reason, sometimes absolute paths are a little bit better to use in some circumstances. Relative paths in many cases are going to be easier and faster to type out because it's less information than the absolute path, especially if you're deep in a directory and you're only one or two directories away, which we'll see here in just a minute. So here are some examples. So /home/user might be an absolute path because it starts with that slash. But if I were already in somebody else's directory, for example, I could do .. // which means go up a directory 3 times and then go back down 1 directory to get into user 1. Another example, here we have the absolute path. So we're going to get from etc to that path. So we're going to go .. which takes us from etc into root, and then /home, which takes us back into home, and then /user1, which takes us into user1's directory. So we could get there by referencing it as an absolute path or with that relative path. And one final example, I could start, if I wanted to get to home, I could just put /home. Um, but I could also type just a tilde to get to my home directory, or maybe just dot dot takes me up a directory. So if I'm in user one and I want to get out to home, I could just type dot dot enter and it'll take me up one directory when I type the change directory command. And by the way, all of these would assume that you're using the cd command to move around through these directories. CD is short for change directory. I'm sure you've used that in the past in other classes. So when we're referencing file and directories with our file commands, we have to specify their locations with a path unless the item is in the current directory. So if the item is in the same directory you're in, you can just reference the file name. Otherwise, it has to be a path to get to, tell the system how to get there. So if you're, for example, passing a file into a command, or you want to open something with a command like VI, if you type VI, you have to tell it how to get to the file you want to open. You'll have to either give it a relative or absolute path, or if it's in the same directory, just the file name will work. And it can be in one, so as an example, you're not limited to just using relative or absolute within one command. You can use relative for certain things and absolute for others when you're typing out long commands that maybe have multiple files that they have to work with. So you can certainly mix and match these. So let's take an example. Let's assume that file1.txt is inside home user 1, file 2 is inside home user 1 temp, and then file 3 is in home student. So what does this look like, right? It's kind of hard to follow in words, so let's look at it graphically. So I've got my home directory, there's a user 1 and student. Inside user 1 is the temp and file1.txt. Inside temp is file2.txt. And then inside the student directory is file3.txt. So these are some examples of how I would reference these different files, assuming that I am in home user 1, right? So follow home to user 1. So one way to get to those directories, you can see the dot dot takes me up a directory, and then I can go back down. So for example, if I am in user 1 and I want to get to file3.txt, that relative example that's in the first command, on the end of that first command, has me going up into the home directory, back down into student, and then into file 3. But I could also reference it with its absolute path. I could just put /home/student/file 3. So in all three of these commands, the first argument will get you to the same file. The second argument gets you into the same file. That third argument that you see takes you to the same file, just showing you different ways to get there. And this little graphic can help you see and visualize how that works. One of the things that's really important to develop when you're working with Linux a lot is being able to make sure that you can visualize these paths. So as you're working in these directories and moving around, it's helpful if you can kind of keep kind of a map of where you are in your brain. It makes it a lot easier to navigate around. If you ever forget where you are, you could always type pwd, which is print working directory, and that's going to show you your current location. And we're going to play around with this in the practical assignment, so you'll kind of see how that works. So if you recall, a path environment variable, hopefully you learned about this in previous classes, is basically that tells the system where it can go by default to look for files. This is why whenever we are running commands, so for example, when you type that cd command to change directory, or when you type the mv command to move something, you don't have to put the full path to that command. Where is that command actually? It's usually in either /usr/bin or /usr/sbin, right? One or the other. But we don't have to type out that whole path to run those commands. We just type the command, even though they're really just files somewhere. So how does the system know where to find those? It's using the path variable. So the path variable, it's one of the variables that we can change in our environment, tells Linux, or tells the kernel, where, or bash really, tells bash where it can go to look for things when you're just typing the name of an object without giving a relative or absolute path. So if you don't indicate a relative or absolute path, if it can't find it in the same directory, whatever you typed, it will check those path variables to see if it can find it there before it returns an error and says, I don't know how to get to this, I can't find it, it doesn't exist, right? So you can add additional paths to the path variable. If you've got a bunch of files you use all the time in your home directory, in your environment, you could add your home directory to the path environment variable, and then it'll reference that every time you type something, so it'll always go and check your home directory for it, right? Some of this could get messy if you're not careful, but you could certainly do that. So this is what the path variable looks like when you're setting that. So if you're in the bash command prompt and you want to see what's in your path variable, you can type echo path or a dollar path rather, and it will show you what all the different path variables or what the path variable is set to, all the different paths. And you can add additional ones if you wanted to. And we'll talk more about environment variables later in the course. So one other thing I want to talk about briefly in this slide deck is going to be wildcards. So, or another term for this is expansion or globbing. This is where you can use wildcards to match on multiple characters to help you find things or help you reference files. This gets a little bit more complicated. It's one of the ways that we're going to kind of dig in a little bit deeper than what you did in the previous course. So some examples of wildcards are things like the asterisk, which will match pretty much anything. So for example, if you type ls space star, it'll say just list me everything. I don't care what it is because the asterisk is a wildcard for everything. But you could also put ls space asterisk.txt and it will match and list any files that end with .txt, but it doesn't care what's in front of that. So it's a nice way to kind of say, okay, what's a list of all my text files in this directory? And there are other wildcard patterns that you can use. We're going to get into pattern matching in a lot more detail when we talk about regular expressions and set and awk later in this course. But for right now, these are some basic options you can use when you're using things like the ls command. Many commands support globbing, and a lot of times when you look at the help or the man pages, it will tell you that it supports globbing. So you know that you can use these wildcards when you're working with referencing those paths. Even commands like the move command or the copy command you'll be able to use. So for example, if I want to move all my text files from one directory to another, I could use asterisk.txt. If I have, file names that all have a number at the end of the file name, I could use the list of characters in those square braces to try to list all the numbers after the string that comes in the file name. So again, we're going to kind of play around with these examples in some of our labs. So here are some examples that you can see, right? So for example, if you type ls_star.txt like I was talking about before, it's going to show every file that ends with .txt. If I put the asterisk before and after the dot, it shows all files that have a dot somewhere in the file name, right? So basically all files that have an extension, right? And by the way, file extensions are not something that's required. Linux doesn't really use file extensions. Windows does. A lot of times programs will match on files based on their extension. For example, Windows knows that if it's a .txt, open it with Notepad, .docx, open it with Microsoft Word. Linux doesn't really care. It uses the header in the file to determine what to do with a file. So it's not always necessary to use file extensions, but they're useful for us, right? For people that are looking at the files and they want to kind of get a sense of, of what we can do with those files. So ls star is just going to show us all files. File question mark dot star. So that's going to show me anything. It starts with file, has one other character, and then something at the end, right? So that's why it matched on both the .dat and .txt versions of those files. If I do ls file question mark, that's going to show the file 2a and file 21, right? So 2 characters and so forth and so on. I don't want to go through all of these because you can read them, right? But you get the idea. There's lots of different ways that we can match these various patterns. And I wanted to just show you one more slide. This is from your textbook. One of the examples that it gives when using wildcards. Why would I do this with something like the ls command? If I'm looking for certain files in certain directories, you can see there's 2 examples at the bottom. By the way, the top is just a graphic so you can see what the kind of the lay of the land is of that system. You can see the map of all the different files and folders on that system, directories I should say, not folders. Folders is kind of a Windows term, right? We say directories usually in Linux. But I needed 4 different, I needed to use 4 different paths with the ls command to find all the files I'm looking for in the first iteration. But by using globbing in that second example, I did it all in one command, right? So I can just type it one time and it'll find everything. As you get better with understanding how globbing works and how to do this, it gets a lot faster, right? Or you get a lot more efficient at using systems. So while some of this may be something, I guess what I would say is, could you get away without using globbing and wildcards? Absolutely, right? You can do everything you need to do without wildcards for the most part, but it will make your life a little bit easier to really understand how this works and to practice it. And then in the real world, you'll be able to do things a little bit faster, especially faster than the next guy that doesn't know how to do this.